All right, this is section 3-7, equations of lines in the coordinate plane. All right, so let's review. All right, true or false? An ordered pair describes the location of a point in a coordinate plane. That is very true. An ordered pair can be written as an x-coordinate, comma, y-coordinate, or a y-coordinate, comma, an x-coordinate. False. It only can be written as an x-coordinate and a y-coordinate. The ordered pair for the origin is 0, 0. That is true. All right, vocabulary builder. What is slope? Right, the slope of the line n between 2 points x1, y1, and x2, y2 on a coordinate plane is the ratio of the vertical change, which we call the rise, to the horizontal change, which we call the run. Slope is rise over run. So the formula for slope, which we need to have memorized, is y2 minus y1 over x2 minus x1. So complete each statement with the appropriate word from the list. Use each word only once. All right, the blank of the hill made it difficult for bike riding. The slope of the hill. The driveway blank down to the garage. The driveway sloped down to the garage. The blank lawn led to the river. The sloping lawn led to the river. All right. Draw a line from each word in column A to its corresponding part of speech in column B. Linear is an adjective. Line is a noun. All right. So complete the table below and find the slope of line A. So here's line A. I know the slope is the ratio of the change in the y-coordinates over the change in the x-coordinates, which the definition m equals y2 minus y1 over x2 minus x1. So the points on line A, so here are the points we're going to use, 5, 7, and 2, 3. We're going to plug in those points. So y2, here it is x1, y1, x2, y2. So we have 7 minus 3 over 5 minus 2. So that leaves us with 4 over 3. And that is your slope. All right, equations of lines. So we're going to use two equations of lines. The first one's called the slope-intercept form of a line, and it is written as y equals mx plus b. M is the slope and b is the y-intercept. The other one is called the point-slope form, and that's written as y minus y1 equals m times a quantity, x minus x1, where m is the slope and x1, y1 is the point. So here's the equation, y equals 3x minus 4. The first thing we recognize is what form is it given to us? It is given to us in slope-intercept form. So written as a fraction, the slope is 3 over 1. 1 point on the graph is 0, negative 4. That is the y-intercept. So from the y-intercept, I'm going to move 3 units up and 1 unit to the right. Now let's graph it. So step 1, I graph 0, negative 4. I go up 3 units, 1, 2, 3 over 1. And I can do that again. Up 3, 1, 2, 3 over 1. And then I'm going to connect the dots with this little line as much as possible. So there we go. Okay, how do we write equations of lines? So what is an equation of line with a slope of negative 1/2 and a y-intercept of 2? So here's the problem-solving model. I know the slope is negative 1/2, and I know the y-intercept is 2. So what's the equation? I'm going to use the formula y equals mx plus b. Now the equation, I plug in what I know. Y equals negative 1/2 x plus 2. Done. All right, now I have 2 points. Okay, so here's the equation. It goes through the line 3, 5, and negative 2, 1. Okay. So I'm going to start with the point-slope form. This is called the point-slope form. Okay. I'm going to substitute in the slope. So it rose up 6 over 5. And I plugged in the point, negative 2, negative 1. All right. So this is called substitution. And then I simplify my work, and I get the exact same equation out. Or it will be the same. Okay? So if I'm given an equation in point-slope form, can I change it into slope-intercept form? Well, yes, you can. So step one, what you're going to do is distribute the slope. So you have y minus 5 equals 6/5 x minus 18/5. We're going to add 5 to both sides. Y equals 6/5 x minus 18/5. Now, plus 5. When I write plus 5, I'm changing that fraction to 25 fifths. Same denominator. When I have a fraction, I add or subtract, you need a same denominator. So we have y equals 6/5 x. And I'm going to combine my numerators here, and I get plus 7/5. And there is your equation in slope-intercept form. It's the same thing I do over here. Y plus 1 equals 6/5 x plus 12/5. I'm going to subtract 1 from both sides. But remember, when I subtract 1, I want to have the same denominator. So that's how I get 5/5. So y equals 6/5 x plus 7/5. Now look at this. These are the two ones from the previous problem up above. And notice that you get the exact same equation now. Okay, so the equations were the same. So choosing the point -2, -1 gives the same equation as choosing the point 3,5. Thus, the equations, this and this, are equivalent. Okay, so horizontal and vertical lines. What are the equations of the horizontal and vertical lines for the point 4, 3? Okay, so the point 4, 3, over 4, down 3 is right here, 4, -3. All right, every point on a horizontal line through 4, -3, here's a horizontal line, has the y coordinate of y equals 3. Is that true? -3. That is true. The equation of the vertical line through x equals to this point is y equals -3. That's false. The equation of the vertical line through this is x equals 4. That's true. All right, so this is the horizontal line, and that would be the equation y equals -3. This is the vertical line, and this is the equation x equals 4. So notice, horizontal line is y equals the y coordinate. Vertical line is x equals the x coordinate, and it goes through that point. Okay, so a classmate found the slope of a line passing through 8, -2, and 8, 10 as shown to the right. What happened? What went wrong in this classmate's error? All right, so what did the problem do wrong? So how about this? Slope should be rise over run, not run over rise. So they flipped it. So let's actually find the correct slope. So the slope should have been -2 minus 10 over 8 minus 8, which equals -12 over 0. The run, 8 minus 8 equals 0. So the slope is what we call undefined. So if 0 is in a denominator for the slope, we say the slope is undefined. If 0 is in a numerator, we say the slope is 0. And there you go.